And let's more work on this isolated power supply. First I need to play my this live stream on my another device. Yeah. Copyright. It's okay. Okay, I'm live. 27p. Okay, let's start. First of all, here I install little big capacitor in experimental mode. You can zoom in. Okay, now I need to remove this capacitor. Here I install 220 UF. The size is little big, so here I need to install properly with hot glue. 100 UFM, 35 volts. That's okay. Here I need to install hot glue. And prototype. That's it. You can watch the previous work of this live. I have live stream of yesterday. Okay, and now we need to install the transformer and make isolated voltages from DC to DC. Now let sorry about unstabilized video. You can more zoom in from your device. It's okay. Solder this. It's okay. Positive. This work is not possible in gloves, so I am working without gloves. Sorry about this. But I have customer. Salam. Yeah.
यूपीएस ते सवेरे
हाँ जी.
हाँ नहीं रावड़ी
रावड़ नन मने की गया डिवाइस डेट से
हाँ
नन मने की ये पत्रे वजे टाइम बना कारी सही ना
सही है सही मैं सार बगा रावड़ 10
सार रावड़े.
काम आड़ते जाए 10
सही रे सार रावड़े. हाँ
सार में रावड़
सही ना. Okay, now I am disconnecting to install this properly. Previous work. I am connecting the resistor in series. We can use one resistor 3 kilo ohm, but it's not good. You need to install 3 resistor in series. Okay. What do I need to zoom in and set my smartphone? Sorry, it's okay. Okay, now we need to connect this. I need to remove this VCC wire because now we need to provide basics. Metal, I need to hold this PCB, provide hot air, hot glue. So wait for this. It's okay. Need to provide here VCC from battery. But first, need to provide connection on this capacitor. Need to provide here battery voltages again because I replaced the capacitor from 220 UF to 100 UF. The required value for this 100 UF best 100 UF and 35 volts. And now we need to check again our pulse wide modulation with this capacitor. First I need to provide power again to this. This is our VCC pin number 7 and this is our GND pin number 5 and this is our PWM output pulse wide modulation output pin number 6 of UC3845. The same pin configuration we have for UC3842, UC3843, UC3844, UC3845. Okay. Pin 1 feedback, pin 2 compensation, pin 3 iSense, pin 4 RT, CT resistor and capacitor timing. You can adjust your frequency with this pin number 4. Pin number 5 GND, pin number 6 PWM output, pin number 7 VCC, pin number 8 VREF voltage reference. It's okay. Now we need to provide again here 9 volts to check the PWM output. This is my negative. Here I am providing negative and this is my positive for this. Okay, connected. And this is the multimeter. Little zoom out. It's okay. First of all, need to check the voltages on pin 5 and pin 7. Okay, and for output PWM, wait for it. Okay, the voltage is 7.8 and the required voltage is 9 volts. Now check. Yes, we have true voltages. The PWM are working. Just check. Yes, and pin 6 output for little time. Yes, with my experience, we have PWM now. We can check with oscilloscope. Okay, oscilloscope. Power supply first. Okay, probes. Negative with pin number 5 G and D. I'm connecting here, and output we have pin 6 for PWM output. We need to check. We are not receiving. Why? Yes. Wait for it. Wait. I'm increasing voltages. We need to generate auxiliary voltages from this single pulse. Okay, once we provide a voltages to this transformer, in yesterday live I wind this transformer. Example, here we have primary winding. First we need to provide this single pulse to this winding, and after that we can receive the auxiliary voltages for this modulator from this auxiliary winding. I start yesterday from here to attach this modulator here with hot glue, and now I am live with this. It's okay. So for next step we need to have N-channel MOSFET IRF 640N or IRF 630N. Okay, so yeah, I'm getting IRF 640N. The N is most important and last. Okay, IRF. Okay. This is the N channel MOSFET, and last we have IRF 630N. Okay, here I'm using, but this is the good MOSFET bar here. Some Chinese. I'm using here IRF 630, good bar, 12 volts. And one more thing required, gate to source discharge resistor. You can use here a 20K or 33K for gate to source discharge. The important thing when you are using the MOSFET, you need to connect the gate to source discharge resistor. So first of all, I need to connect here gate to source discharge resistor here. First we need to get output voltages, and after that I need to connect the heat sink. But I think don't need for heat sink. I am just providing a power to just one IC and solar hybrid inverter, and here I need to make isolated power supply for one MOSFET and IGBT gate driver HCPL 3150. It's okay. The gate to source discharge resistor is installed. And now let's do more work. We are receiving the pulse wide modulation. So once we apply on transformer, we can get output stable voltages. Okay. Oscilloscope, no need now, so I need to keep here. Okay, this capacitor, don't know. Okay, now here I need to install this MOSFET with hot glue temporary, and here I need to use little, it's okay. Yes, hold it. Okay, now I need to provide negative to this source. Okay, and this is the battery wire, so I need to cut here and solder here, because do not use like this. First you connect the MOSFET source, and after the IC you need to connect the star configuration. So I am working on star configuration. Okay, we can call this configuration star configuration. It's okay. Twist wire. Okay, one more thing required, I sense resistor to limit your current, because if we have short circuit in our output, the modulator can limit the current. So here you can install I am using 470 milliohm per ampere sense. Okay, and you can use here to connect with source. Okay, source pin, and now I need to cut this here. To limit our current, little I need to zoom in. It's okay. And now we need to provide I sense to this pin 3 from this source, because here we are dropping the voltages and the modulator can sense this drop voltages, and modulator can limit your current with this sense. Here we provide direct negative voltages, and here we need to install 1 ampere sense resistor. So here I am using 1 kilo ohm for I sense. And you can limit your output current with this resistor, from this pin to this pin number 3. So here I am using 1 kilo ohm. possible. First I need to make here angle. Okay. To isolate from more fans. It's okay. This is the pin number 3. I sense. Oh, my hands are shaking. It's okay. Connect with this. Okay, I sense completed. Now we need to provide feedback and install the transformer. But first we need to provide feedback because the modulator are providing 50% duty cycle, and we can last our PWM modulator and MOSFET and transformer. So we need to provide feedback. For feedback we need to have PC817. Okay, auto coupler. Okay, and how you can use this is the PC817 pin number 1. Here we have dot 1 2 3 4. So connect the pin number 4 with modulator pin number 1 and connect the pin number 3 with modulator pin number 2. Right. Howdy. Walaikum salam. Howdy.
دا چیک دی
ها.
د نو باسي نو کې ډېر فیچرز دي
هاي.
دا سیم چیک دی کنه
هاي.
چې زموږ سره یو دو یو پی اس دي یو میلان د ستاد رول ورکو
هاي.
هغه د لاس په جوړ دی کنه
ها.
د یو دا مسله ده چې دا منګو لګو وس لګه تا ته ټوله قسم کومه
ما د مکه نشته ضرورت زه چیک کولای شم.
نه دا زموږ بلفونه نه دي بلفونه
هاي.
بلفونه زموږ سپسي
هغه به تاسو په وایرینګ کې مسله کنه
نه کنه وایرینګ وس تا ته قصه کوم ځکه دا خبره ده
زه دا شی ټوټل چیک کوم چې زه به تاسو مکمل په طریقه پوه کوم. ښه تاسو به فکر راشته. ښه دا زما کار دی. صحیح ده. دا ټوټل سیستم ما جوړ کړی دی لاره. موټر تاسو ټیک دی 230 بجلی واسي. صحیح ده. او فرق تاسو چې دی کنه دا تاسو چې کوم ځای کې لګوي کنه په څه طریقه چې لګوي نو په هغه ځای کې مسله ده. دا په لګولو کې تاسو په غلطه طریقه لګوي. دا ګوره داسې حساب دی کنه
جی
دلته زموږ سره راځي دا لاین دی. ټیک شو.
دا مارکر نشته ما
لاین لګوم کرخه ده په کومه دا لاین دی نو کم چې په بجلی کې زموږ سره هارت لاین نازي کنه ګرم تار چې راځي
او جی او
هغه به دی لور کوي.
ٹھیک شو.
صحیح ده چې دیخ په تراشي.
ها
صحیح ده. نیوټرل کمباین تاسو استعمالوي او بیا به آوټپوټ چې دا ګور دي زموږ سره لیکلي مې خبا قاعده لاین نیوټرل
او دا دغه نو
صحیح ده. نو په دې 3 وانډر ته نه خو کما هغه یو تار چې دی تاسو کنه هغه به پدې کې کېدای. او واستله دا د کومه چې دا د چیک کومه
دا چیک چې دا په ګرم باندې دی کنه
دا د چیک کومه.
صحیح ده. ځان ګرځم هغه ګرځم
एक तरफ पानी ने हमारा अस्पताल का तरफ पानी गरम राखी कराई को जुगिया टिक के अदर फाल्ट देखो रसात की चार्जिंग आउटपुट अगर स्पदी के पद गजर पानी जमा लाइन वर्जी अखु माता पत्र जब मुतमइन है सही दा पदी तरफ दे लाइन बासी खा
सही दे
दा बदी सुला कोई नहीं बिया मसाला नहीं खा यू बिया
बस सही दे ठीक ठीक शो मेरा
ला
भाई
ले
دا جوړ کړو په منګوره کې مته ته مې دا جوړ له دوی نه دا نه دی جوړ
لا لا ما
بس مش مسلا شو بس تي
بس
أبل جيش.
أبل لازم
بلا
ها
okay sorry for that but this is my duty to provide service for people it's okay and I am making this isolated power supply for inverter not like this and this is my previous projects in 2021 this was my active balancer PCB proper PCB okay now okay I need to little set my smartphone more zoom it's okay where we were okay negative here install it's okay this is our main negative from battery and now we need to provide source provided now we need to get the drain so here we need to give our transformer so for better result here I start the primary winding from this S that's okay so I need to provide little hard glue to just hold temporary it's okay now this is our starting this is our 0 volt winding pin okay so I need to provide 0 volt I'm providing here negative cut the wire from here to here I need to cut this wire from here to this drain okay. Do not use the extra wire with frequency okay we are talking about the feedback you need to connect the pin number 4 1 2 3 4 4 with pin number 1 3 with pin number 2 why I am providing you more data okay cut this extra fins from here solder this in one it's okay PC 817 pin 1 pin 4 and pin 3 required to connect okay. Connected pin 2 connected and this is the pin 1 connected I need to cut the extra pins or bend it's okay now one more component we need to have TL431 okay TL431 we have. In this I already use to provide feedback to this modulator. I am removing the TL431 from this old PCB. Okay. And here I need to install this TL431. Okay, and one output capacitor, filter capacitor need to install. So here I'm using 220 UF for output, and one more Scotty diode we need to install here. Negative. It's okay. Now, first of all, we need to work on input. It's okay. So for input, need to install here positive first, the transformer. Okay, positive to transformer. Here I need to provide little hot glue to this wire. Okay, and now I'm providing positive first to transformer. And it's okay. Get the extra. It's okay. And negative we need to provide from MOSFET drain. This is the MOSFET drain pin. It's okay. Minimum. All right, it's okay. And this is our output, and this is our auxiliary. So first we need to connect the output. One thing requires Scotty diode. If I have a small size, but I have one in very small size 1206, and another I have Scotty diodes. I think if I have little Scotty diode, Scotty mean low resistance diode for high frequency. And how we can check, to zoom out, how we can check this diode is Scotty or not. Scotty diode, you need to have 0.25 something continuity. Check. It's not Scotty. It's not Scotty. First check. Here I have Scotty diodes, Scotty dual diodes. Okay. Just check. Okay, this is the Scotty diode. So here I am looking for small size Scotty short key is 6, I think. What is this assembly package? Is this the Scotty or not? 0.3. Okay, we can use this. What about this? Not Scotty. Okay, need to use this, but the size is very big. Okay, use this to finish this work. So here I need to provide, this is the diode positive side. This is the diode positive side. So we need to provide here. We have space or this or not. We have, but I need to remove this TL431 to move this from here. Okay, this thing I need to install here to work easy. Okay. Need to use here. It's okay. This is our diode. Okay. The input is completed, and now we are working on output and for feedback. How we can provide output feedback to provide you a constant voltages. Okay. And after this live stream, when I done this project, I will share you all the schematics on white page. Okay, don't worry about the connections. Now here we have positive, so we need to provide positive for this capacitor from this pin. So bend this here and cut solder positive. It's okay. Here I need to connect with this capacitor positive. Hard to remove the insulation. So in mid-little project you can provide hot air and you can solder easily. Okay, positive. It's okay. You need to provide here negative direct with this from transformer output winding 0 volts. I am providing the 0 volt pin. Okay, this is the starting pin, 0 volt connected, and now need to connect here. Okay. Solder. It's okay. Connected. Now positive. So we need to connect these pins to use dual diode. It's okay. Here, here. Center pin is common for positive, and here we have one diode negative. Oh man, another. Okay, cut this here. And white positive, so we need to use the red wire. It's okay. We connect with this pin. Connected. Okay, output feedback. How we can provide output feedback? Okay, first we need to connect the output capacitor negative with this TL431 pin number 2. Okay, TL431 pin 2 need to connect with output capacitor negative. Okay, so here I am connecting, provide. Okay, and for feedback we need to connect the positive with pin 1 first. Okay, I am using here 33K I am also using, and after that I am sharing you the data. Okay, for pin 1 we need to first connect this with 33 kilo ohm resistor. It's okay, connected. And I need to provide positive voltages from output. It's okay. Positive. It's okay, connected. And what about the feedback provider PC817? First of all, you need to connect the 1 kilo ohm resistor on this pin 1, pin 2 on LED side. So here I am using SMD 1 kilo ohm to save the space. 1K SMD, it's okay. This is the 1 kilo ohm SMD resistor, 1206 size, better for this. Okay. So I am connecting here. 1 kilo ohm. One side is connected, another side. This is the dummy load resistor, okay, to save the PC817 live. Okay, connected. How we can control? I'm checking with the multimeter, connected or not connected. So here we need to have 1 kilo ohm, okay, 0.995, because we have tolerance in resistors. It's okay. And now we need to provide positive for this feedback provider. We need to connect the positive, the pin number 1 is positive of this feedback provider PC817. So this is the pin number 1. We need to connect with this output positive. Oh man. Okay. Here I need to connect this with this output positive. It's okay. And what about negative? Negative, we need to connect with this TL431 pin number 3 output pin with a 1 kilo ohm resistor. So here I am using dip package resistor. This is the output pin of this TL431. Okay. Yes, I can remove this from MOSFET drain. That's okay. No, negative from here to here. It's okay. This is the negative of this feedback provider PC817. because here you are providing here 12 volts, because positive are connected with the positive. Our nominal voltage value is 12.5 to 13 volt. So here we connected directly with positive, and here we provide negative to this TL431. So when the feedback come here, so they are providing output 12 volts. So you need to install 1 kilo ohm resistor. For this auto coupler. Oh man, just solved. It's okay. Now we can adjust our voltages with this pin number 1, and we need to provide here negative with 10 kilo ohm potentiometer. Here I have a 10 kilo ohm potentiometer in this old PCB. I'm removing this to adjust my voltages. Okay, if you want to increase the voltages with clockwise, so you need to connect this pins. I think the pin number 1 and 2. Okay, I need to connect this together. It's okay. And after that, first of all, I need to connect this here. Here I have diode, but I can connect. Okay, first I need to provide wires to this potentiometer. Okay, I need to provide 2 wires for this potentiometer. I'm using this for negative, so I need to use black wire, but the black I have little. So okay, here I found black wire. Okay, it's easy, not hard, and I not play approximately 1 year, but now I need to play again, because I need to design this PCB properly, because I am receiving complaint in solar hybrid inverters, so I need to design properly. Okay, I'm providing here hot glue to hold this potentiometer. Okay, connect here. It's okay. The little bit required. Okay, and we need to connect this side with negative output. Connect this with negative output. It's okay. And another side wire to this TL431 pin number 1. This one. It's okay. Now feedback provided components, it's okay. And the time to apply the voltages and check here. Okay, so I need to use my probes. Here I have note that wires. Check the output voltages. Okay. Negative, output negative. It's okay. Little zoom out. Output positive. Why? Look. Aha. And Mr. Bloke, what do you do with this? We have just 2 to 1.5 millimeter distance. It's okay. Right it. Now connect with this. Complete zoom out. It's okay. DC voltages here, positive, negative. It's okay. And now provide power to receive voltages. Okay, we have not just the auxiliary input, and we need to install one more short Scotty diode and one little capacitor to provide here auxiliary input for this modulator. But we are just checking the output, and we can receive little output voltages without auxiliary voltages. So here I am providing voltages. Positive, crocodile clam, okay, and negative. Here we have, okay, apply, and PWM. Oh, one thing forget it. PWM output to MOSFET gate pin. Okay. MOSFET gate pin and gate drive resistor required. It's okay. The gate drive resistor here required 22 ohm. So I need to connect the 22 ohm. I have an SMD 1206 size. Oh. It's okay. This is the gate pin of MOSFET number 1. Connect. Just I need to set this in this one. Okay. Get voltage is provided. Now again connect. Okay, zoom out. Comment receive. Japindra Basial. Hi, how are you, man? Okay, now provide. Ah, ha ha ha. We received isolated voltage. I don't know, man. What happened? What happened? What happened? Ah, feedback. Feedback, man. Ah, feedback we already provided. Then why? Where from here is smoke? Oh, from MOSFET. Why? Okay, one thing we have. Note this. 0 volt and 12 volt winding. Now we need to reverse this. Okay, how? Because now I need to know about and I need to know this data. We receive voltages, but we have extra consumption, so I need to provide here the positive to starting point or 0 volt, and here I need to the end winding. This thing is little puzzled and I need to remember this for next time, and I need to note down. Okay, now check. Okay, little wait for this MOSFET. The hot glue is melted with heat. It's okay. And, okay, now check. Oh, we have extra consumption. Okay, again reverse this. Why, man? We have extra consumption. Okay, now check. Oh, extra consumption. What about feedback? Feedback. Actually, I need to set the feedback. Why we have issue? Because I wind this with formula. Then why? Output frequency we have 32,000 kilohertz. 32 kilohertz. It's okay. Now okay, reverse the output. Okay, this is the output wires. This is the end point of this winding, and this is the start. So I need to install here end for negative and start for positive and check. We have voltages, but we have extra consumption. So now reverse this with this, because this thing is not in my knowledge, and now I need to keep in my mind. Okay, now check. Now we have very high consumption on input. So positive input, it's okay, and negative from MOSFET drain, it's okay, and we provide source, everything is fine. And why we have extra consumption? We have issue in our transformer. We can confirm this because I winded this transformer for 68 volts. So let's just remove the transformer to check why we have issue in our transformer, in what thing we have issue. Using okay, red. Okay. Just remove this transformer. Hot air required. Install this transformer. Why? Forgetted the pins data for this transformer, but I can remind. Okay, here we have lots of winding. Can measure with ohm or not. Primary winding. Okay. Yep, I can know about from here the deep wire. Okay, the deep wire is connected with this pin. So I think this is my primary. Need to check how much okay, first we need to check the 0L 0.1 ohm we have in probes. Okay, and what about this winding? No any continuity with this. What? man. Maybe how much continuity? 0.5. So resistance is 0.4 ohm. Okay, what about this? 0.4 ohm. It's okay. And what about this? 0.4. Okay, and what about this? 0.4. And this, okay, what about one here and another is here? No any continuity. 0.4. So this is the 0.3 ohm continuity. Oh, 0.1 continuity ohms. So how we can know about our input, because I not right here. I think here I have issue. I'm just soldering this pin. Okay. Continuity 0.3. Oh, I think I remember. This is, I think, the input with this pin. No man, in mega ohm not. I need to solder. We have dust, I think, on this pin. I'm thinking about if I wind this like this is all deep wire. So if I count here, 2 pins, another 2, and this to one winding, this to another, this to another. Yes. Connect this. But we have 0.3 ohm continuity. Okay. Connect this with this. No any continuity we have. For center pin, what about, man? No. No continuity with other pins. Just continuity with this. Okay, confirm this. This is the one winding, 0.3 ohm. If you are thinking we cannot provide in ohm, we have resistance in kilo ohm. Okay. So this is our winding 1. No continuity. Okay. This is one winding, 0.3 ohms, 0.1 ohm. Okay. And what about this? 0.4 ohms. That's okay. And what about this? 0.3. And what about this? 0.4. Little I am remembering I want this for input, so let's connect with this, man. We cannot lose billions of dollars. Little time we can lose. Okay, so in my experience I'm using this. So we need to set here. We need to learn more from this. Here I am here wording positive. What I am doing, man? Yes, okay, positive. I'm right. And negative from this MOSFET. Okay, and what about output? Here I have one near winding. Okay, negative. And here I have another winding field, positive. Okay, mix it with multimeter voltages. It's okay, set on volts. So can now provide negative. We have consumption on input, but we are not receiving voltages on output. So what's the reason? Okay, here we have two more pins. But why I fail in my previous transformer, man? Why not check the frequency again? Let's install our design transformer for this. I waste my time, I think. I wired this transformer yesterday for this purpose, and I provide turns for this. Start, end, start, end. That's okay. And here I provide for auxiliary. And let's again check. Positive input, MOSFET drain, okay, and start output. Okay, provide one pulse. Yeah, we have. Oh, complete start. No, man. What about our feedback is working or not? You can check with this. Shunt the pin number 2 and pin 3 are here. You can shunt to check your PWM pin 1 and pin 2. And now when I provide voltages, feedback, why? Okay, shunt with some good conductor. Okay, shunt. Our feedback network is not working. Here I provide compensation voltages to this. Pin 5 to pin 2. In a shunt, we need to close the PWM. I think the MOSFET, we need to check the MOSFET. Okay, remove this probes. Okay, check the MOSFET. Okay. Ah, the MOSFET was shorted. Okay. Little I need to use here high voltage MOSFET first to the red voltages and check the feedback. IRFB4115. Okay. It's fun. Why? We have issue in our MOSFET. I will work then. I am replacing this MOSFET. Okay. And get source discharge resistor. It's okay. Right, right. Huh? Nah, my okay. Here I am using IRFB 4115. Where is the hard glue? Oh man. The hard glue disappear. Why? This is enough to hold this MOSFET for me for a little time. Okay, check this MOSFET first. Okay, and provide gate voltages to check. Okay, we have true MOSFET. It's okay. Source to gate discharge resistor. Important thing. It's okay. And this is the drain pin. Okay, drain. And now just need to connect the gate pin. It's okay. Now check. Okay, why not check the modulator in this circuit? Okay, negative on pin 7, positive on pin 5. You need to have internal resistance. We have, after that, keep the negative on pin 6, 0.637, and here we need to have more than resistance. That's okay, the modulator is okay. Now connect the probes. Voltages. Provide single pulse. Yeah, now the system is now good. Everything is fine. Okay. How much voltage is we are receiving? Oh, 11.8 without auxiliary. Finally, never give up. Okay. And now I keep in mind 0 volt you need to provide positive power input, and you need to provide same data like here I start this now we have 10 milliamps consumption on input and we are receiving a voltages on output, and you can adjust here. Okay, check output feedback, but I think our modulator feedback network is not working. When I shunt this two pins, okay, so we need to down our voltages. Yes, our modulator are working. So what about the feedback voltages? Okay, remove these probes to check the output feedback. How we can check positive with positive, okay, and negative here we have on this pin, okay, and how much voltages we have on output. Oh, no, we cannot read with this meter because I am hearing a noises. Okay, what about we need to have here 1 point some voltages, okay, on this feedback provider, but we have not any voltages on this feedback provider. Why? Negative already we have from main capacitor, and positive we have one positive. So here we have positive, and negative. We have 13 volts. We have not any voltages on output pin. And how you can confirm? You need to keep the negative on pin 2, and here when we have 2.7 voltages on this pin, so this component is responsible to provide this negative on this pin. So how much voltages we have on pin 1? The voltages is not enough on this pin, so we need to decrease our negative, provide here a feedback, but other side we have no auxiliary input, but does not matter. Okay, now I think sound is changed. Nice, sound is changed. So how much voltage now we have? 3.8 still. Now we can adjust 11 point. You can more adjust to increase this positive resistor like this. Why not decrease more? I am connecting one more 33 kilo ohm resistor in series with this. No, you need to connect with parallel, because we are decreasing the voltages, not increasing. So we need to connect one with parallel, so we have from positive two parallel 33 kilo ohm, so 16.5 kilo ohm we have. Now just check. Okay, now we have a 6.7 minimum. Okay, and now we can adjust at it's okay 9, 10, 11, 12, 12.5, but we not provide auxiliary voltages. Just check how much voltages we have on our PWM modulator, GND and VCC. Oh, meter. Okay, meter is connected here on with output. Okay, we have 8 volts. So if you are running a high load on your PWM modulator, you need to provide auxiliary, and now I am providing auxiliary because this was my promise to provide auxiliary. Oh, this was the beautiful. One more, but why this MOSFET, Chinese MOSFET chart? We need to focus on this next time with first pulse short. Okay, the transformer now running. I need to it's loud. Everything. Okay, now I am thinking about auxiliary. Okay, for auxiliary we need to have one capacitor. Already we have capacitor. We need to have just one diode, just one Scotty diode and 10 ohm dip resistor. Scotty diode, this 10 ohm, 10 ohm, 3 watt. Okay, this is the 10 ohm resistor and one Scotty diode required for this. Here I have use the RS1J. This is the RS1J we are also using in solar hybrid inverters. Is this the Scotty or not? No, it's not the Scotty, but you can use this because I look in solar hybrid inverter and I purchased this for solar hybrid inverter auxiliary. So we can use this. Let's try. Okay. Remove this. Okay. And now negative with negative. Here I winded auxiliary, so this is the start. We are also using start point for positive and end for negative, so I need to connect here negative with negative. This is the auxiliary. Okay, end pin we are using for negative, so here I need to find white color because no more black color I have nearly. Need to connect here. It's okay. Negative. With negative and for positive, need to connect the resistor here with this starting for positive, so I'm using okay. Okay, connect here. Diode. We need to connect the diode negative with winding with the resistor and positive with modulator VCC. It's okay. Little more wire required to connect this auxiliary, and this is my first time experience to provide auxiliary to UC3845. Yeah, pin number 7 VCC. It's okay, connected here. This diode. It's okay. Now check. Okay. I think no, we have extra consumption. How much? Why the auxiliary? First check the voltages, auxiliary voltages. So now we need to remove this from here. We need to attach here negative and positive. Why this power not working properly? It's okay. Now start to check the auxiliary voltage. 9.6. There we have extra consumption. What about resistor? Oh man, I need to replace the windings. Okay, I'm just replacing this. Why auxiliary? Start man. We need to run some load. Okay, now check. Oh, 42-volt auxiliary, no working board. Why, man? Ha. What is this? Auxiliary. This thing was hard for me. I said in yesterday live. This was my first time experience to provide auxiliary voltages. And then and what about the output voltages with this condition? Let's check, man. What about the output voltages? What is this, man? This is the fluke instrument, and why? No. Okay, little I need. Oh man, but it's not good thing. Why? We cannot use this for this. Okay. Now check the output voltages. What about? No. We have fixed voltages on our output, but have extra voltages. 24 volts on auxiliary. Okay, little we need to learn from solar hybrid inverter how they provide auxiliary voltages to UC3843 or UC3845. Little we need to learn from this. Okay. I need to provide charge to my smartphone. Charges and it's okay. Little we need to learn from this. This is the charging transformer of this inverter, and this is the modulator UC3843. And here we have auxiliary winding in this transformer. This is the auxiliary winding of this transformer. Okay, so little connect the 10 ohm resistor, brown black, it's okay, 10 ohm, connect with winding, and after winding they connect with diode negative side, and after that the diode positive side are direct coming here on this line to pin number what is this? Another? Why? Positive? Okay, how we can confirm Okay, I'm using here multimeter. Okay, I'm checking this. The winding is connected with 10 ohm, as you can see, and after that here we have one diode. Okay, and after diode need to have continuity with the pin number 7. No any continuity with pin 7, so we cannot learn from this. This is difficult. Why? Connected with this capacitor. This capacitor is connected with this modulator. Okay, no. Okay, negative. This capacitor is connected. Okay, this is the auxiliary input, and this is the modulator pin number 5. We have continuity with this, and after that here we have 10 ohm resistor, and after that here we have one diode, and after diode we need to have continuity with pin 7, but we have not. So let's check the components on top side. No any component we have on top side, so I need to learn from other man board, from Growart. Okay, this is the Growart PCB, and I can learn easily from this because I repair this a lot. So this is the auxiliary input. Here we have 10 ohm 1206 size resistor. Okay, and this is the auxiliary winding. Okay, I am telling about you with continuity because there we have circuit. The auxiliary input one pin is connected with the modulator pin number 5, and after that we have 10 ohm resistor, and after 10 ohm resistor we have one diode, and after the diode we have a capacitor like this, a UC3 at 4. What is this, man? And what about the capacitor? Negative. We are connected. Capacitor negative. The capacitor negative. Simple thing, man. So this is my mistake or what? We have high voltages on. Okay. Little. Okay, first I need to set this here. Move this. Okay. We are connected. I have another multimeter, so why I am okay, difficulties. Connect this here. Common. Okay, and this one we need to connect properly with the output voltages. Okay, connect negative to check the output voltages and remove this auxiliary because we have extra consumption. Okay, 11.3. And what about the auxiliary? Get this meter. Cannot see it. So check there. Yes. Negative. And this is auxiliary. They connect here. At 8 volts. And when I am connecting here, we have extra consumption. So let's think about why. Here I use positive for S. Okay. I think we have to issue this resistor. Okay. Diode. Brown, black. That's okay. Why? I need to install here small size resistor of 10 ohm. This thing is little hard for me because my first time to set the auxiliary voltage is 10 ohm. Okay. SMD small size 10 ohm. Need to connect with this. Oh man. It's okay. Now I need to connect this diode to check first. This one here. Okay. Now connect this to check. We have extra consumption. Okay. Remove this diode and install A2 diode. And Zener diode. Okay, let's install this little diode first, and after that I need to install Zener diode on UC3 at 4, 5. It's okay. What about before the Zener diode? Check the data. Extra consumption we have. So okay, I need to install here diode, Zener diode of 18 volts. 18 volts on pin 5 and pin 6. But the 18 volts is good for this. 15 volts. Okay, I'm just getting the zener diode. Okay, here I'm using zener diode on UC clear 45. What? Okay. Negative, negative. Positive. And, positive. Let's check. Okay. Ah, we have extra consumption. 380 milliamps for this. This is very high consumption. If we are providing auxiliary. How much voltages we are receiving on auxiliary now? Positive, negative, and we provide auxiliary voltages. 9 volts just, and 370 milliamps current are consuming. Wow. Why? Start positive and negative. Okay. No. Okay. Little bit. I need to replace this output and check. Sometimes we have issue in this. We need to learn about this. Okay, now provide voltages. Okay, 8 volts on auxiliary. Now no any work or no any reaction with this. The same auxiliary voltages we have, no any extra consumption we have, and how much output voltages. we have in this time 12.5. I received my output voltages. Now I am working just on auxiliary input method. Learn this. Okay, why not reverse the auxiliary system and how much voltage is we are receiving. Remember one thing, I am confused. Why the kilowatt install here? One capacitor more per auxiliary and the capacitor are connected. Negative, positive with one diode, and after that they install again one diode. Wow, so we need to learn more in this company, but in simple SMPS, in this control drive cards, we have just simple diode to use auxiliary voltages. Auxiliary voltage. And this is the important thing. What's this? Remove and walls. Have gone. Man. Hello? Salam. خاص تاسو د یو پی ایس ټیک دی چې خاطر باندې څه مسله راغلو یا به دا بیټرانې ناستي دیوه نه مسله به کې نشته خال ته څه مسلې بیټرانې به یا ناستي okay now reverse the wires attach here as attach here and this attach here. Okay, now check. What is this? Not working. Auxiliary. Auxiliary are not working. But what I do? Oh man. This wire I place on wrong area. I place this wire here and this wire here. Now check. Okay. Now we have 8 volts on auxiliary. It's not good. What about the Zener diode? Okay. When I cut the Zener diode, what happened? The voltage is low from Zener diode continuity at volts and output we have 12.6 volt what about the input voltage? Resistance. Auxiliary. Okay, little. We need to work more on this. Um, okay. Here I'm using one more capacitor for this auxiliary. So we need to remove this. No, not remove this and negative. To connect positive with this winding, starting point are 0 volt. After that, we need to connect. Okay, remove this wire to make this work easy. What is this? Oh man, and now remove this. But this is the positive. So here I need to connect the negative here. Positive here, and now start the power supply. Okay, now check this capacitor voltages. Oh man, 12.8. But what about be provide to IC? So already we have positive here, okay, we have still voltages. Walaikum salam.
भैया ना जमीन का बेटी चला होगा
Kumayo?
बनतारे वाला निराना
Aga pasara kai se braga biya raga khatarnak ho mai da shewdai.
हाँ
Wodi da kha. Sa number osaro ma tu khuma khore de se wo sara.
हाँ
Aga taklif no ta.
हो वरना
Wodi da kha she khatarnak ho mai udai. Warega. Pratara da na. A doctor matle bezer azam anai da pratara.
दादा जो मोटरसाइकिल लावला मग ना
Sai da kha.
हाँ ما वया ما تبي يا قفل ما تزين मालूम ما قفا ما
Okay. Already I connect the positive with positive, and now I need to connect negative with negative. So little I need to cut this wire because I have no more black wire, so we can use this. We need to work on this, not impossible, but now I need to use this circuit and water, and I need to fix everything properly. Now I am trying to connect negative with the negative. I guess here we have negative. It's okay. I need to connect this. Oh man, what you are doing? Take care about the multimeter. But this is my multimeter. It's okay. Connect this with negative. Before this, how much voltages we have on this capacitor? 12.8. And when I connect this with modulator negative, the positive, The positive are already connected with positive, and now I am connecting the negative with negative. Ah, again we have still issue. What is this? We have some more components we need to install in this. What about 10 ohm? This. Oh. Okay. No man. I'm little increasing the input voltage. No. Still we have. Issue. We have 12 volts, but mm, 13.5 volts. When I'm connecting this negative with modulator negative, they are dropping. Okay, what about diode? One more diode. So this is the negative. I need to provide the diode. No. Anyone have idea for auxiliary? Because yesterday I already told the hard thing for me is auxiliary. Otherwise I said all thing we can adjust our output voltages, but if I see working for me, I need to install this because auxiliary input are using for high current, and I need to just run one HCPL MOSFET and IGBT's gate driver IC. Another side, just increase 14, 15, wow, 16, 17, wow, you can adjust, that's okay. .5. What about load? If I need to run little load like 100 milliamps, I need to connect. I'm connecting this motor. What about our current? Haha. Okay, how we can okay. Okay, I need to hold this motor. Okay. They can provide Ah, this is the auxiliary need. Ah, now we need to have auxiliary. Why not start this load properly and provide auxiliary? Okay, remove this. We cannot use high load on this because remove this first from here and solder this. Okay, because the modulator have not the auxiliary input, so we cannot use high current. Okay, and now what about the auxiliary negative? Oh, the motor are starting little quick. Just check when I'm using auxiliary. Ah, started. So what is this, man? Okay, what is the magic in this? Okay, simple negative without this capacitor. What about before this? So the positive are already connected with positive. So what is this capacitor? What for, man? Okay. Now little speed on. Oh, started. Oh, the flux. Okay. What about the MOSFET? Just 200 milliamps on input. And this is the output. Yes, we can adjust. Now check the auxiliary input. What about the negative and positive? Wow, we have 11.57 voltages on auxiliary. But what about, okay, just remove this wire and start again. We need to more work on this. Little bit I'm thinking about. Started but not perfectly on time, so here I use resistors, 3 resistors of 1 kilo ohm. I need to bypass one resistor from this because it's just for 12 volts and I use 3 kilo ohm to know about. And remove this confusion from here. Okay, connect to the negative. Okay, and this is just going into pin 7 on auxiliary method. Okay, now check before bypassing this. Okay, now check. Oh, quick started. Oh, we need to run some load on our output so we can get the auxiliary voltages. Yes, start. Again we have issue not quick starting. Okay, now run, but not properly run. So bypass this with 10 ohm. Now we start. Okay, you check. Wow, started quickly. Again, quickly. Okay, again. Yeah, auxiliary. Okay, what about auxiliary? The auxiliary voltages. Wow, very cool. A 12.5 voltages on auxiliary. Okay, thank you for your time, and I finally design and make the SMPS isolated power supply. Okay, and from how much voltages we can start, so I need to show here. This is the input voltages and the output. As you can see, this is the input negative, and this is the input positive voltages. Okay, turn on the meter. Now we have 12.9. I need to decrease 10. At when we apply at, we can get output 9.5. Is this the feedback network issue? I need to increase. No, this is, I think, the iSense, but oh, at 0.1. Okay, 9 volt minimum, 9.5. The minimum voltage is required 9 because we design from 9 to 16 volt. Okay, now I need to set my voltages again. 12.5. Okay, now I am increasing the voltages. Generating sound 16.8. Okay, no any heat we have. Okay, decrease the voltages. 11, 10, 9.8. Okay, again start. Oh, again we have the issue. Start. The voltages is low, 10 volts. Before this I provided 13 volts. My man. Okay, increase the voltages to check. So what about, okay, bypass some more resistor. Little wire required. Okay, here I have one wire. I need to just right here 1 kilo another. I need to bypass this resistor. So this is the mean. This was my first time auxiliary knowledge to use my auxiliary voltages knowledge. quick start from 14 volts. Now 11 volts. Okay, so capacitor. Now it's starting from 10 volts. Ampere sense. What about the ampere sense? I need to shunt. No, not related with ampere sense. Related with the resistors.
No, this is not my dear friend. You was always honest and tell and have dealing with people.
Yeah, man.
Bakay ka ma? Uli. Nagpataman sa straight, naman na kung wala po, masyuro na sana maralig ako. Paisi negative, asin haste. Paisi huli pa makawala.
Okay, I need to add one more capacitor. Mister, nulla male c'era una. 220 UF to start on one time. Okay, and provide complete pulses. Here I am adding one more capacitor with this capacitor. I need to little watt for this. Okay, now check 10. Wait for it to charge the capacitor first. Oh, not working. It's okay. With high capacitance, we lost more. Okay, remove this and decrease the capacitance. Now check. With load, okay, 10 volts. We cannot start our system completely. From 11 volts we can start. It's not good. So we need to decrease the capacitor more. Check. What is this? I am not running load like this. We need to work on this, but we have little difference. We are starting from 11 volts, and what is this? We are just making isolation. So I need to check my work with this, because I have a lot of inverter and I need to repair this inverter in live streams. Just check. We need to repair this one grow watt and one Prominus and one lithium battery, and other side I have to close this inverter and repair this. I am making a power supply for inverter, so Next time we need to work on this. But we are now able to provide auxiliary. Now the issue is just that the low voltages, we can start our system from 11.5. Just check. What is this? Okay, I need to hold in this 12.5. Okay, provide 11.5 because the bench power supply is not constant, so little increase. Okay, now we can run. So this is mean our auxiliary input are working. Okay, we have fixed output voltages. Okay, 16, 18. I think this power supply are working for me because I am just running this IC. I designed this power supply just for this component to operate this HCPL 31T20 per solar charge controller, MPPT solar charge controller, to provide here isolated power. One man of King. Hi, how are you, brother? Okay, so I hope this is enough for my project. What's your opinion? Okay. What's your opinion, man? I am just coming again in 10 to 15 minutes. I need to do brunch because I am hungry. No. خراب هذا كان بس طول سنة خراب شيء.
نقصان خو بنا كي يورو.
لا نقصان لك.
لا.
Okay, I am coming in 10 or 15 minutes. Okay, and I need to check this power supply and quite perfect. Oh man. Okay, close this live stream. I complete everything, and now I need to assemble this with confidence, with single mind, because when I am live, I'm thinking about the camera. 1 minute of getting up here, 1 minute of getting 4 volt DC to 12 volt DC step up, please. How we can generate how much amperes required, man? One man F King, 4 volts DC to 12 volt DC step up, and how much current required? I can this. Let's check. 2 and 3 amperes. Yes, possible, but first you need to use the 3.7 volt modulator, and other side we have a boost converter. You can use this step up converter to just run your modulator. Okay, to just run your modulator. Wait. Boleh banjara. Nah, pusat network masalah itu macam Tata sawai, tata woi so mobile. Network tata sawai. Network tata sawai tami lauga. Ah, ta network tami lauga woi so. Sawai, sama saras.
Nah, taruh telepon koma, biar orang ni.
Da dai este o scandam mai de preхода de number no me mata pata no ce diu malik tu de number de
Tata ji kram marji, kram mata, tadi tata.
da pun number but smart di vera ce
Boleh tata mau mana sih sampai dia mata mi bajana. Tata ji
ana da bia zaman sara de data de mun sara de pa zapar panum eu zaman ma tra de du tamare agara gale be na ma ya puri gari kala ku para zapar na kala na ma ya kala ku wala be na ma kam
tata ji mai sampai dia.
sajidun bisone kan deo
Kau sangat malah dia sengaja.
ما كل او كل حسيت دي خبر ده بروتو انا هننزل روبي خاطر بيراجي
Amin zara. Sebut kalau.
يرى ورجع شو دادي
देख दियो फिर कार कर ले चाहो
ना खराब दी है 509
Zamang dah baru lah kerja saya.
Bisi paja na yakin mo kada mas aka 70 dia mun da stop ko pa ba ya padi ke आराम का रास्ते की
Boleh nak saya.
ना
Nah, nama saya masuk zamang dah baru suruh saya.
كذا يرى جدا
Saya kata mah tahu orang kan saya dah.
استاد بقول هو اللي بيقول مطاد مصر كان كل يرى بزمان بيجي خلاص
Mama sudah beda. Orang udah teman ini udah jadi main del biar orang mama kerja deh. Sana roda. Baru saya sedih kalau kan. Sedih kalau udah nih. Kerja nih.
زه په خپل مزدوري نه ودی په او دې سو روپے وته په کټ نو دا شي تاسو زیری شي نو دا 9000 پیسو ده
9000 tahu.
9000 پاند مين ده نه دونه ورسنه دا دي جامو حالت ته ده ورغو مګر سستا ده مخې نو کا سجو کړی جام بس ته ورغو باندې امر څه نه کیږي خپل
Jadi bagi building motor.
دا منګر دا زمونږ ټول دې دم بس ته ده مرمت کې هغه دال او به خلک لوي مرمت په خپل کې ته وایي ته مرمت کې څه دي کوه نو مرمت ما څه وکړه او جو خورو بس واړه ماړه په ګډه باندې كان بارك وصلت لهم ان انا كنت بتعمل من اوراد كبيره كده صباح كده صباح ما كده ما كده
તમે ટીમ ચલ કહું તો બિજલી पे बंद રાખલા પલ પૂરા જે મારે સાથ બાજુ બેવ લગી
نه هغه خو د دې سر نه دی خو چې مړ شي بیا خو یو پیر دی بیا بس دغه شي کار پرې دی بیا کار پرې خو دی
ها دا یو ته تل کړه یو څه ځای به بجلی بند نه ولا پل پورا سو بند کې ورشته
Jadi kita masalah razi kayak
نه نه دې چې بس راشي به بیا به دې سی لګا دا اوس چې راغل
دا سٹارټ کېدو باندې ویډیو ستنه نه نشته
بس په نو اوس زیرو نه کړه خو دا کس دې چې بن شي بیا دا کس جو باندې دا نه نمبر وای تاسو ما
360
Real 93
301
301
हाँ चौबीस
Num
बस
Num غفار
محمد غفار غفار خلاني
بس زبرة سبا إن شاء الله تليفون تمخا وخبو قربان قربان تشيرا
ممكن انت خراب شيء وما تقدر تقول مردان تخلق في كلام مردان تنقله دول كلام بس هذا خلق في كلام ماشي فتم شو
نمبر
بس هذا ما من
Okay, sorry for wait. One man came. Okay, just. Okay, first I need to. One man king IRFZ 44 and channel MOSFET. Yes, you can use. You make. No, I just make this for my project for my solar hybrid inverter repairing. My English not better. Same with me, man. I am not English speaker. But hope provide here like this. Your first comment 4 volt DC. So first I need to provide 4 volt DC. And after that you have a lot of schematics and circuit diagrams for boost converter, but the difficult thing is that from 3 to 4 volts, so you can use this device, you can easily purchase online. Okay, first you need to provide here 3 or 4 volts and set the output voltages on 12.5 volts and use UC3 at 4 5 or UC3 at 4 3 to just boost your voltages. This is the easy way. Okay, and now I need to close this live stream, but no new viewers are come and join. Okay, see you next time with the next inverter complete repairing, and I need to fix this all components first and provide here varnish and some epoxy to hold these components properly, and after that you need to come again live to show you how I control. Okay, see you next time. Good luck, take care. I'm coming. Okay, see you next time. Take care.